We welcome all the participants and hope that you and your families are keeping safe at home. As you're aware, we've been working on a series of webinars. We had our first webinar a couple of weeks ago, and those who were part of that and are here today, we welcome you again. And those of you who are here for the first time, we welcome you and hope that you will be part of our ongoing webinar series. The webinars have been designed some in anticipation of the information that we've come across through our journey. And we would appreciate feedback and questions that we can that will help us designing the future webinars as we move forward, so that we are better aligned with the requirements and needs of the industry, of whom you all are a critical part of and represent. During the course of this presentation, we will today be attempting a few interactive questions, so do keep a lookout for that on your chat box. So you'll find a chat or a conversation tab on which we would request you to look out for some of the questions, an interactive set of questions that will pop up periodically. And we will also request you to drop in your questions in the chat box, and we will be answering them at the end of the session. Some of the questions that came up in the previous session that could not be answered, a few of them have been picked up to be answered at the end of this session. So once again, I appreciate all of your time and attention, and look forward to your participation in this webinar and also as we move forward to the other webinars. So with that, I'll be starting. This webinar is focused on designing an Olympic size pool using MYRTHA technology as per FINA. So this just gives an overview of the topics that we'll be covering. So introducing what Olympic size pools are, what is introduction to MYRTHA technology, what is circulation, case studies of Olympic size pools. While in the previous webinar, we had given case studies and examples of swimming pools that MYRTHA Pools has built around the world. This time we've chosen to focus on case studies of Olympic size pools that MYRTHA Pools India has been working on in the subcontinent. And then we'll be, of course, ending with a Q&A session. I'd like to quickly introduce my team members. I'm supported by Mr. Jaishankar Arunachalam, who's the National Sales Head based out of Bangalore, and Mr. Saif Nadeem, who's the Sales Manager handling North India, based out of Delhi. My name is Hakimuddin Habibullah. I'm the Managing Director of MYRTHA Pools India Private Limited and look after the Indian subcontinent region. I'm an Olympian swimmer myself. I swam for India at the Sydney Olympic Games in 2000, and also an engineer. And that's where, again, my love for technology as well as swimming comes together with MYRTHA. A very brief intro on the company for those who are new, who newly joined us today. We, as an organization, we are headquartered in Italy. We have a presence in over 70 countries, a pool built in over 70 countries. We have 270 direct employees. The company was founded in 1964, so we are, 1961. We are now approaching our 60th year. We have 5 subsidiaries in the world. India is the first one for Asia. We have 400 representatives and the most important thing that again gives us a lot of confidence in sharing information is that we build 1,500 swimming pools a year, and on an average 100 Olympic-sized pools. So MYRTHA Pools is the official partner of FINA, along with some of the biggest swimming federations around the world, the USA Swimming and European Swimming, to name the two biggest federations that MYRTHA Pools works very closely with, besides FINA. We have been consistently since 2008, been involved with the Olympic Games and building pools for the Olympic Games, and also the World Championships. Our first ever swimming pool for the Olympic Games was built in 1996 in Atlanta. So for those of you, can just look up your chat. There are a couple of interactive questions in your chat. Would just request you to spare a few seconds in answering the questions that you might find on your chat. To begin with, what is an Olympic-sized pool? Okay, so if you're able to see the options in the chat, the options were 100 meters, 50.025 plus or minus 0.005 meters, 50 meters, or all of the above. Well, for those who may be interested in some trivia, the answer actually at a general level is all the above. So like I said, from a trivia perspective, actually 08 Olympics, they had a 100-meter swimming pool that was built. And then in 1924 Paris Olympic Games was the first time that a 50-meter swimming pool was introduced, which has subsequently since become the standard. 50.025 plus or minus 0.005 is the tolerance, is today, where the dimensional tolerances that are what is accepted. So this next slide gives you a context that, because in India, often when I would hear of an Olympic-sized pool, for most people is just a 50-meter pool. So we decided to just give this bit of more context, because a 50-meter pool is not a 50-meter pool. The details matter, because you need the dimensional tolerances of 0.010. That's the difference. That's the acceptable tolerance given by FINA. I'm sorry. So 50.010 is the maximum tolerance when touch pads are in place. When you do not have touch pads, then wall to wall, it is 50.020 to 50.030. That's the wall to wall detail. And today we've seen in India, that's been one of the challenges with many of the former pools that have been built, that there have been some of these challenges in the dimensional tolerances. But this is the level of detail that we are now involved with, and FINA looks closely at towards recognizing any world records or Olympic qualifications. So this slide gives a little bit more detail as per FINA. I'm sure some of you might be aware of it, and for some of you it may be new. But this, so when we're talking about even the measurement of the tolerances that are required for 50 meters, it's touchpad to touchpad, because you have to anticipate timing systems, and the timing systems should not exceed 1 centimeter on either side. So then your wall-to-wall tolerance should be 50.020 to 50.030, and they have to be measured 0.3 meters above the water surface, and and has to be consistent up to 0.8 meters below the water surface. Like the previous slide indicated, you have the touch panels that come from 0.3 above the water surface up to 600 mm below the below the water surface. So even to ensure that the touch panels are well positioned and to give everyone a fair opportunity to compete. Another, just for, in the past we've had many asking us questions of whether, how does the swimming pool get certified by FINA? So for those who may be interested in that part, FINA defines it that it needs to be certified by a surveyor or a qualified official appointed or approved by the National Swimming Federation. In our case, in India, it will be the Swimming Federation of India. So the question of why choose an Olympic-sized pool? An Olympic-sized pool is one that, so often we come across people looking at Olympics, bigger the pool, the better. Or so to give an example, in Bangalore, where we are headquartered, we have an anticipated at least 20 or more 50-meter swimming pools. Majority are built by the municipal corporation. Some of them are built by the armed forces, and then today we see a mushrooming, a growing number coming up by private enterprise as well, and schools. But an Olympic-sized pool means it's a 50-meter pool and needs a careful attention in terms of usage, because normally the pools have to have enough number of programs and participation to make sure that it's financially attractive and can be maintained in a future context. Another big reason why competition pools, 50-meter pools are built is for competitive training. So today there is a growing number of swimmers across the country that are looking at competing and would like to have the basic infrastructure, which includes the length of the pool, to be able to train for competition. So 50-meter pools are today being built to support those who want to compete. Again, just to go back to usage, like to give an example, in the US, today we see close to 500,000 users, active competitive swimmers. And for every one of them, there are at least 5 others who are not part of a competitive program, but love to swim for health, fitness, recreation, leisure, but have the competency to swim the relevant distance. So we normally see swimming pools in more mature environments being fully utilized, and hence there is a greater demand for Olympic-sized pools. I'll keep using Olympic-sized and 50-meter pools in turn, so because that's what, at a very elementary level, the two mean. To just also clarify, when I'm talking about Olympic size, and which will also be further defined as we go through the presentation, there will be, you will see a difference between an Olympic size pool for general use and Olympic size pool for the Olympic Games. So we'll come to that towards the end, but also just to introduce the subtle difference between the two at the point of design. And then when you get into the details of competition, then there's further critical attention required on the details, on the dimensional tolerances, and then some of the other aspects when it comes to circulation that my colleague Jaishankar will now take forward from here and introduce more about MYRTHA Technology and how it intersects and facilitates meeting the FINA requirements.
Okay, thanks, Hakeem. Good morning, everyone, and I thank you again for joining this session. Uh, MYRTHA Technology. Uh, while introducing MYRTHA Technology, there are three major components to begin with. The first is structural part. Uh, as I said to you earlier, also in the previous session, MYRTHA Technology is an Italian technology, a pre-engineered technology, almost for last being used for last 6 decades now. When there are three major components are the steel structure, the PVC membrane flooring, and finally the finishes. So the stainless structure is nothing. It's nothing but it's a PVC laminated factory laminated structure, which is basically 2 mm, which is about 0.9 mm wide, and there could be various length. The membrane is actually a special reinforced membrane, which gets complied to EN standards, and it's only used for the swimming pool purpose. Finishes. So this particular technology allows various kind of finishes to actually come on the top. Let it be the ceramic tiles, let it be the other metal items which gets into the structure. So this is largely about the technology. I also feel that we should also cover, because during the entire course of presentation, we will be talking about various accessories in the design also, which would come up as an element or accessory of design. So we think that these also element needs to be explained, which MYRTHA also takes care while designing and detailing. For example, the leftmost one is a backstroke ledge, which becomes a part of a starting block, which is there in the third slide. So the starting blocks are completely properly designed by MYRTHA by taking utmost care, considering for the swimming pool requirement altogether. So that's the backstroke ledge. The one which is the head wall, which gives the flexibility of actually creating a platform around the swimming pool on the shorter ends, and also allows a four-way. Most of the time, it allows a four-way water circulation. The third one is the starting block. Now you could see there's a complete detailing, including the fin behind, the slope, the kind of material. There's a provision of actually having a kickstart system, then which all gets assembled into the starting block. Then these are the anti-waving links on the rightmost end. Now, while this all looks very prima facie a very simple element, but FINA also gives very strong guidelines on the quality, on the kind of specification for each of the item to ensure the quality of the material as well as the quality of the competition. So these are the other special equipment which becomes a part of the most of the pools. The left one is a movable bulkhead, which actually helps you to create a split in the pool. So this actually creates a vertical barricade and also acts like a movable deck. It comes into the pool. So you can also see a starting block being placed. So in one of the projects what we are going to discuss, you could see how this is being used. So this barricade in one of the projects also takes care of the thermal insulation. So that's the vertical barricade, what you could see, which is called movable bulkhead. The right one is a very extreme, very interesting thing, which is called a movable floor. So this allows the floor actually to move vertically from 0 to 2, 3, 5 meters up down through hydraulic or other methods. So these are few elements which you will see, which are very important in the swimming pool, which you will also see in the during course of a presentation being used in one or the other applications. Now, before we getting into some examples and design, we would also like to highlight why MYRTHA is able to achieve, or why MYRTHA is a FINA partner, how we are able to achieve the compliance at most of the time. So if you look at uh, we MYRTHA being a pre-engineered structure, the structure is manufactured using a state-of-the-art manufacturing facility. Working on the most advanced softwares and being equipped with the modern research facilities, we are able to deliver a very high quality pools each and every time at every part of the world. So, and adding to that, our installers have been given regular training periodically at a pool academy, which ensures to get a very high end finished output, which then finally meets all the compliances like dimensional tolerances, water circulation as laid by FINA. So these all process we believe, right from innovation, comprehensive design, process of manufacturing, quality control, these all are the ones which helps us to deliver a FINA compliant pool every time. By saying so, I am actually telling you why water circulation. By saying so, I am also touching on the subject of water circulation. If you look at on account of water circulation by FINA compliance, Now we follow a computational fluid dynamics and especially in-house design inlets called star turbulence. You could see the topmost images are of the inlets. The left extreme shows the flow of the water into the swimming pool, the energy dissipation you could see from the high to the low. And the last image shows the circulation, water circulation in a proper manner all across. I will explain in the next video how this water circulation happens. But coming back to the CFD again, with CFD, that is a computational fluid dynamics, we are always able to predict the proper distribution of chemicals and ensure that the heated or treated water is distributed throughout the pool and there is no stagnant or dead point anywhere in the entire pool is also very important. The specially designed inlet, which I just spoke to you about, is actually placed about 0.8 meter below the below the water level, so that it does not affect the flow, does not affect the first lane. But the way, if you see one of the cross sections, the flow just goes down in such a trajectory that the energy gets continuously dissipated without creating any turbulence or current, without compromising on the discharge speed which is required for the turnover of the water as well. So these all we're able to achieve because of a proper analysis on the CFD and a specially designed star turbulence inlet. Now I will show you a small video which we have done. A small dye test which we have done in Barcelona, with where you could see the dye moving into the pool in a standard time as required. So if you could see, the entire dye had reached out each and every point of the pool within about 9 minutes 23 seconds. A standard time as per EN standard for these kind 50-meter pool is about 15 minutes. So as I said to you, the kind of the CFD analysis what we done earlier and the kind of inlets, we are able to achieve the dye reaching the extreme point as well as taking care of the discharge of the water. Advantages of the technology what we are trying to present here, as compared to concrete, MYRTHA brings in a lot of advantages on the table to a user, to a designer, as well as to the owner of the structure. With MYRTHA, as we have explained earlier also, we give a turnkey solution for the pool and the water treatment, which is an integrated solution which takes care of lot of issues per se. If planned well, we can have the entire pool in much shorter time as compared to a concrete technology. While in the previous slide we did speak about the FINA compliance largely for the dimension and the water turbulences, MYRTHA brings in a lot of flexibility to the structure by its innovative engineering solutions as well. So any kind of pool can, if you see the leftmost image, it is actually showing a split bulkhead. So you can bring in a lot of solutions into the pool in the same structure, which is a bit difficult in the concrete, which is more rough and finally a rigid one. In this MYRTHA technology, we're able to do, as we keep saying internally, we just keep tinkering the minds of an architect to actually come with some kind of solution or some kind of expectation, what they look at. So we are on that. We also, while with this innovation, we are able to also take care of multiple programs. We can address larger group of people. We can bring in aesthetic appearance. So MYRTHA is answer to all on these aspects. Materials. Even the materials what we use, while they are largely maintenance free, but we also take care that they serve the function for which they have been actually been deployed for. So to deliver the desired function. Above all, which we have not covered in this slide, MYRTHA technology is one which is we can use in a condition where the site location or a site conditions like an elevated pool or a pool in a seismic zone. So MYRTHA can be used in those kind of situations as well, where concrete could find some challenges. We will get into the Olympic size. We'll get into design detailing of Olympic size swimming pool. So if you look at the competitive training, these are the general conditions what we propose. So for any kind of competitive training pool. So this is for a training purpose, not for the competition purpose. But yes, competition till local level could be handled, not an international competition. So the length is 50 meter, which is respecting the tolerance of FINA guidelines. Width is a 2.5, but in this case, in the example what we are going to speak is we have taken 25 meters, but it can be a multiple of 2.5 meters. The depth profile could be 1.35 to 2 meter preferably. We could have 20 starting blocks, put both as a very good condition, but even one on each lane could serve the purpose. With 25 meters, we will have about 9 lanes. Ledges each on each of the starting block. We will have 6 numbers of recess ladders, footrest along the shorter end at 1.2 meter level, backstroke indicators on both the sides, both the extreme ends of the pool, head walls 2 numbers on the shorter ends, and if required to accommodate any special program, multiple people, various kind of activity, we can always have a bulkhead. So as I said to you, it can be for a high performance training as well as local competition. So just getting to an example, this is one of the pool which we are now executing in. We are under stage of discussion or under execution at in north of Karnataka. Now this particular pool is actually, if you look at, is a combination of a diving pool plus a swimming pool. So this particular pool, if you look at, has a depth profile of 1.2 meter to 5.2 meters. So you could see the one end being used as a diving pool. Actually, this particular region where this particular pool is coming up has a history of divers holding some national records as well. So that's old. It's a old way of constructing a swimming pool. But this particular location, they chose to have a diving pool plus a swimming pool together. So if you look at this if I take you to the plans, yeah. So there are we are considering overflow system, a 2 sides overflow system, which is on the longer side, and we have a ceramic head wall on the shorter ends. So if I will show you the next, you'll be able to understand the. So this is the 3D perspective which you could see. So these are the longer ends where you have the overflow, and these are the shorter ends where we have the ceramic head wall. This is the ceramic head wall which I am referring to, while there is no overflow from here. So this is connected to a RCC structure at this particular end. This is a panel on the top. On the shorter, if on the longer ends, we have overflow of this kind, which is a gutter. There is a gutter on the sides, which takes care of the overflow. Now this is a panel which is on the longer sides. We also spoke about. So this particular pool, what we have done largely is this is entirely a 51 meter pool with a 25 meter width. Now to accommodate a bulkhead, which is now placed here, you could see the pool length gets extra by 1.5 meters. So 50 becomes 51.5 to take care of the bulkhead. So the bulkhead when comes into the center, it actually becomes 225 meter pool where you can actually have a 25 meter course and still have a diving. So both can happen as a parallel activity. So it creates a utilization to the fullest, and also it takes care that there is a barricade. When people are diving here, the people who are learning at 1.2 meter don't unknowingly or by mistake accidentally get into this area. So this creates a kind of barricade. So bulkhead creates solves two of the requirements here. You also see the membrane used in this particular portion, since it's 1.2 meter, it is actually an anti-slip kind of membrane. This is a regular membrane. This particular portion where people tend to walk because the height being only 1.2 meter, this is a special anti-skid membranes. Yeah. So as I said to you, all the elements of the pool, the staircase, the anchors, everything gets, neither they jet out into the pool, neither they are outside on the deck. They are all within the gutters. So this makes the entire pool very safe to access, use, and perform. This is another example, this is an indoor pool, which we are basically an indoor pool, which we are doing, which we are in stage of discussion again. Similar kind of pool with a lesser depth profile at 1.2 on one end, then the gradual up, and then finally it moving up to 1.8 meter. It is actually corridor type pool. You could see there is again an anti-skid to facilitate people to walk. Overflow on the four sides in this case, and starting blocks on only one end, because this is the only end where you can actually dive in from. So we have a restriction of diving in here because it's 1.2. Even in the previous one, if I look at, the diving is not possible unless there's a bulkhead here. So if you see, when the bulkhead comes in here, the diving is possible on both these sides. When I mean diving, it is to start from the starting block. So I want to correct that. Diving doesn't mean from the top diving. Diving actually means to dive in to start your swimming. So this is possible in these two regions when the bulkhead is moved into center. So similarly, for this, we have only the starting blocks are only in one portion, as you see in this drawing. It's only at this end where you can actually start in from. You cannot dive in from this particular place. So these are the elements which has gone. So this is a recessed footrest which goes on the shorter end, this end, for people to take rest or finish their racing, which doesn't project out. It's a part of a structure. There's another view. This is a recessed staircase or steps, as you say, to access the pool. These are three kinds which becomes a part of a structure. These are the multiple multi-use anchor sockets, which can, now this one is largely for the anchor bolts, for the floating lane anchors, which is now getting into the gutters. With this, I would like to invite Hakim again to actually speak on the further projects. Hakim, to you now.
Thanks. Thank you, Jay. I see again there are quite a few interaction and questions being asked in parallel. So I will try to see, to the extent possible, how I can integrate some of your questions while I'm speaking, and sharing these examples. So first of all, this is an excellent example of, to begin with, on how you can still have an Olympic-sized pool of 50 meters, but have a variable width. So while the previous two examples still had a 50 meters by 25 meter pool at a very general level, this is a 50 meter by 12.5 meters. So this is an indoor pool project, which we are in the process of executing. It is a pool that had a constraint of space available in width, because it's going to be an indoor multi-level multi-sport complex. And so they could only go up to 12.5 meters. So it still makes it an acceptable Olympic-sized pool, but of course you cannot hold an Olympic event in it. Coming to some of the design detailing, because the client had a unique requirement. He wanted it to have maximum utilization because it was a private for-profit center that was being created. And when you're looking at this particular challenge, they wanted a balance of high utilization, which comes predominantly from teaching swimming and recreational swimming. So they wanted shallow water, and they wanted deeper water as well for more competent swimmers and for competitive swimmers to have their at least junior level coaching programs effectively done. So we had to, sit with the client and the architect to kind of find a best balance of the design. So this is actually one of a very, very unique project currently in the Indian context. To begin with, the conversation was how do you probably focus on building a swimming pool that can scale with usage? Because, like I said, it was built for with a business context. So the initial solution being explored with the client and the architect was where we look at them building only a 25-meter pool, shallow pool, that can allow for the initial business to be initiated. And then because of the MYRTHA technology, which is, like Jay has introduced earlier, it's a pre-engineered solution, which is modular and so can be easily integrated, and we can upgrade subsequently as well. It allows for the swimming pool to potentially be upgraded in the future. So the initial design looked at this pool being built in 2 phases. The first one being the shallow part of the pool, and then with the provision being made for the expansion of the pool in, say, 3 years' time, as they were able to get their business going. But as things moved along, the client seemed to be convinced that they wanted the best of both on day one. So what you see here is you got 2 pools. It's one shell, it's one body of water when the bulkhead is parked. So if I may show you the bulkhead, this is the bulkhead on your top left, where you can see my cursor moving. So this is the movable bulkhead. Now this movable bulkhead, on a daily basis would be parked in the center, like is shown in the picture below. So when it's parked in the center, now someone had asked a question, what is a bulkhead? Mr. Dharanipati had asked, what is a bulkhead? So a bulkhead is actually a simple way to call it. It's a movable wall, or it's like a bridge, between the 2 ends, which can move. So we have a 25-meter moving wall. So this wall can move and can come here and get parked here, like you can probably see the center. And that allows for the pool to be divided into 2 parts. Now this bulkhead is the additional element that we added to it is that it's thermally insulated. So what that means is it allows, when it is parked in the center, to have 2 parts of the pool with 2 different temperatures of water. So you can have the shallower pool with warmer water for allowing recreational activity and teaching to happen and creating maximum comfort for the users, while the deeper part of the pool could have a different, slightly lower temperature that is probably more comfortable for competent swimmers who want to swim more distances. So to just give an example, this had one of those design challenges that we were able to support the client and architect with. Some of the other unique elements of this project, it's the first project that, so I'll just introduce some of the elements in the next slide. So another, so on the left, on the top left, you might be able to see the bulkhead, dividing the pool. On this particular picture here is a Renovaction technology, which is another component of what MYRTHA offers, where the MYRTHA panels are inserted on an existing structure. So this particular project, the other interesting part was there were 2 beams that were there at these 2 ends of the pool. So because of the space constraint, we had to then find a mixed solution. So here there is a beam running below, and so we are integrating our Renovaction technology, which is our PVC laminated stainless steel panels which slide down, adjoining the existing beam, and the rest of the longer sides are our regular MYRTHA technology panels. And what is also interesting on this project is it has a corridor. So on my bottom right, you will see that this is what a corridor on the bottom right, and on my left, the 2 extremes, you will see examples of a corridor solution that our technology allows. So this means that the pool, all the electromechanical elements are easily accessible for maintenance. So every electromechanical element, all the piping, all the cabling, everything will be immediately behind our panels and it'll be accessible to the maintenance staff. That is the level. So when someone was asking about the waterproofing and the leakages on the joints, for us, we integrate, like between the two panels, we have a special PVC T-joint, which is inserted and is then sealed. There's a double sealing with liquid PVC that happens. So that's between the panels. And then between the panel and the floor, we have the fusing, the hot fusing, the fusing with hot air of the special PVC membrane with the PVC on the stainless steel panel, which is factory laminated. So that's how we are able to ensure waterproofing of the highest quality. And we are able to have the confidence of providing a corridor solution like this, where if there is the slightest leak, it can be visible. So we have the systems in place and the years of experience to ensure that the leakages are well, attention is paid to those details, which also comes to the point that Mr. Jaishankar had brought up in terms of our pool academy, because while we also work with the highest quality elements and components, we also have to also ensure that our technicians that are involved in the installation are of the, are extremely well trained and of the highest quality to ensure that the installations at site are highly professionally executed to ensure that the last mile is to the client's satisfaction. Another part on the top right is an element called the soft walk. So like the design, so to kind of again highlight another component, this shallow area is actually, you have, if you're looking at the profile, the bottom profile picture, to the left, we have a starting block on the deck with a depth of 1.35 meters. The pool comes up over here to 1.05 in the center, and then goes down to 2 meters deep. So at this section between 1.05 to 1.2 meters, is also a sensitive area, where we find children or adults who could accidentally dive with the head first. And so from a safety perspective as a primary, and then subsequently as a comfort factor, we have an element that we integrate below our reinforced membrane called the soft walk. So the soft walk allows for the ability to absorb impact if in case someone accidentally falls. Again, like you can imagine, if someone dived into shallow water head first, it can be quite dangerous. So this allows for some level of shock absorption, and like I said, for those who are there for recreational purposes, allows for some comfort. Moving to the project that that some of you may be familiar with, and has now been operational for over 2 years at Bangalore. It's the Padukone Dravid Center for Sports Excellence. It's a pool that was built. Now, the purpose of this particular pool, the client wanted a pool for high performance training. So this meant that they had to have the competitive starting blocks at 2 ends, and allow for multiple other aquatic engagements. So you have the depth profile is 1.35 meters at this end and goes up to 2 meters at the deep end. This pool has been more recently used for the Olympic trials, for the Olympic qualification meet, which was the Asian Age Group Championships in September last year. So it was built to be a high performance training facility, but by the virtue of since it met all the dimensional requirements, like I highlighted earlier, required by FINA, this pool was identified to be the venue for one of the biggest competitions that India has hosted in the recent past. Just sharing a short time-lapse video, which may give a little bit better understanding of how the MYRTHA system comes together. So this is a time-lapse video of the MYRTHA pool coming together at the Padukone Dravid Center for Sports Excellence. We have a base frame that's installed, on which the panels are then installed. The gutters are being installed here, which are integrated in our structure. We had a little bit of tiling on the edges from an aesthetic perspective. Just keep track of the number of days on your bottom left. This is the membrane being laid down on the floor and the lane lines being painted with a special PVC paint. These are the highest quality starting blocks. We look at sharing a slightly longer video, which has more input from the architect and from the key stakeholders involved, both as users as well as investors in the project. We'll share that with you, with the survey at the end of this webinar. Coming to, like I had mentioned earlier, there's an Olympic-sized pool at a general level for training or recreation. And then there's a swimming pool. There's an Olympic-sized swimming pool for the Olympic Games. So there's a special mention on the permanent pool because, we highlighted in the last webinar, MYRTHA does build swimming pools for special events, and an example of that was the Rio Olympic Games, where the main swimming pool was a temporary pool, which was immediately dismantled after the games and reinstalled in a community for permanent use. But if you're looking at building a permanent pool, an Olympic-sized pool for the Olympic Games, then you would need to have the length of 50 meters with a dimensional tolerance of plus or minus between 50.020 to 50.030. So that's the tolerances as per FINA. The width being 25 meters, the depth profile 3 meters, but we've highlighted in the previous webinar, and I'll repeat again, 3 meters is where we are looking at a single pool being the main venue for swimming, artistic swimming, and diving. And water polo. So these three sports can be done in the same pool, and hence the depth profile of 3 meters. Number of lanes, you would have the 8 primary lanes where people will compete, and you'll have 2 buffer lanes at the 2 ends. So you'll have 10 lanes in all. Each lane will have 2 starting blocks at either end. So 20 starting blocks. You'll have 9 lanes. You will have backstroke ledges. You'll need to consider 10 of them. You'll have 6 recessed ladders. You may have to include 2 more if there is the optional equipment of a bulkhead anticipated. Footrest at 1.2 meters below the water level on the shorter ends of the pool, and a backstroke indicators at the 5 meter mark, and removable head walls. So what I did see a question on whether we have to anticipate if a deck level overflow. Mr. Muthumanikam had asked, is there a deck level overflow drain allowed? So ideally, again, we look at a 4-side overflow is good to have. Sorry. Yes. So deck level overflow is a four-side overflow is what is recommended. And so when you have a four-side overflow, you would have you need two removable head walls. And the removable head walls are elements that allow for the installation of the starting blocks, and as per FINA regulations will have to be 300 mm above the water surface. And compatible to have the timing systems, the automated timing systems, which we commonly call touchpads, to be attached to the wall. So the removable head walls, you would need two at the two shorter ends, which will, again, like I said, have the starting blocks. And the optional element is a bulkhead, which is which you can see a context of in the next slide. Just a simulation video of an Olympic-sized pool. So this basically shows how our panels come together. So the panels here look a bit long because these are 3-meter depth panels. That's the maximum size of panels of single size panels that MYRTHA has. And we have these are, like you can see, you can integrate windows, and you can have the gutters. So the gutter supports are all part of our structure. So every element, including the lights, the inlets. So we have our inlets in the walls. And like Jay had indicated, these are special wall inlets, which are approved by FINA as well and used at major events that meet all the requirements of ensuring no turbulence on the surface, as well as ensure that there are no currents, and that's done by CFD, the computational fluid dynamics. So this gives an example of how the bulkhead moves. So this is a bulkhead that can come together, and you can divide the pool into two 25-meter pools, and you can have one part of the pool used for water polo, a water polo event, while the other part of the pool is used for swimming. So we'll dive into questions. I know last time there were people looking for answers, and this time we will be staying back for more time to answer questions, and we'll be going through the questions in the chat as well as visiting some of the questions that were presented last time. We would for those who may want to leave the presentation, we would request, we would just want to highlight that before you go, next webinar is being planned on the interpretation of the FINA rules, facility rules handbook. We understand that many are familiar with the FINA facilities, but what we would probably, what we would look at going deeper in is the interpretation of how does one look at those rules and understand those rules better. What are the tests? How is the performance of, when you're talking about achieving the desired performance, how is that measured, beyond the dimensional tolerances? So, we'll be looking at that, and we are also planning to have the webinars every 2 weeks on Friday, but since the next Friday is on May 1st, we'll be having that on the Thursday. So please look forward to that. And, we look forward to your participation. Now diving into the questions. So one of the first questions was on what about the depth? So like we've highlighted in some of the examples, the depth profile for an Olympic-sized pool, but not for the Olympic Games, can be of different types. One of the examples we shared, it can be as less as 1 meter in the area where someone is only going to swim. 1.35 is defined as the minimum depth when a competent swimmer is diving. So, we'll get into more detail when we're interpreting the FINA rules, but the minimum depth when we're talking about 1.35 meters is purely based on the assumption that the FINA rules are meant for competent and competitive swimmers who know how to dive appropriately. So 1.35 is the minimum diving depth for that category. And the depth profile can then go down to 2 meters. It can go down up to 5 meters if you're integrating a diving pool in it. So the depth of the pool is open to interpretation and attention based on the type of activity anticipated. But if it comes to hosting the Olympic Games, then, like I've shared with you, it's 3 meters. 3 meters is the recommended depth that one considers today. What is a touchpad? This question was asked by Bushra. A touchpad is an automated timing system that is used increasingly now in India as well. On either end of the pool, it eliminates the use of handheld stopwatches, which is how it used to be done. So when a touchpad is installed, the normal thickness of a touchpad is about 1 centimeter. So today, when we're talking about a tolerance of 50.020 being the minimum and 50.03 up to 50.030 wall to wall is so that we are able to integrate a touchpad at both ends, which is an automated timing system, and records the time when a swimmer touches it. So, Bushra, I hope I was able to answer your question about the touchpad. Mr. Muthumanikam had highlighted that deck level overflow drains are actually preferred, and on all 4 sides are preferred so that there's no bounce back. In some of the examples we've shared, we have considered a 2-side overflow with the shorter side being, with a concrete head wall, but that's, only to find a certain, balance between the usage and the economics as well. But a 4-side overflow drain is preferred from a hygiene perspective. It allows also no bounce backs from the pool. Shraddha Desai has asked, how does one decide the ideal number of lanes? Again, we might have got some context in the examples we shared. There is flexibility on the number of lanes that one may want to consider based on usage and based on the level of competition or competitive training one is looking at doing. So predominantly usage would be the key point to consider. So does every Olympic size pool need to be 50 by 25 meters? The answer is no, if it's not for the Olympic Games. So it can vary. The main thing to pay attention to is the width size. The width of a lane is 2.5 meters. It's a good lane size to accommodate multiple swimmers who may swim at any point, at one point of time, even during warm-up of an event, and they normally swim one behind the other in a chain. So a 2.5 meter lane allows for enough space to facilitate that. But otherwise, one of the widths that we come across as a common reference is a 12.5 meters, which is 5 lanes. That helps in to consider, because while competent swimmers can swim lengthwise, I'm saying 12.5 is the minimum starting point, because while many can swim, competent swimmers can swim the full length of 50 meters, those who are less competent or who are just learning can at least use the widthwise part of the pool. And so if it's 12.5 meters, it allows for then multiples of that. So 25, 50, 100 can become easier for a less competent swimmer to use. So I hope that answers, Shraddha, your question around the ideal number of lanes, which impacts the width of the pool. Mr. Dharanpati was asking what is the dark color, and I noticed that that question came when we were showing an example of the dye test or the water circulation test. Now, the dark color is a special dye that is put into the water, which allows a visual validation of so the pool. So when we design a comprehensive system of the structure with the water treatment, it's designed for a certain performance of flow of water as well. So we have to pay attention. I mean, so while we simulate it using computational fluid dynamics at the time of design, we are in a position to also validate it at the time of test and commissioning using the dye to help the client. And and in Europe, for example, it is also mandatory in many municipalities that this has to be validated at the time of test and commissioning. So it just allows a visual confirmation that the filtered and disinfected water is effectively being pushed and reaching every part of the pool. At the same time, also giving an indication of the subtle parts of visually, if you're able to see any turbulence on the surface or currents that can impact the swimmers. Shraddha Desai has asked, can the mobile bulkhead be introduced in existing pools? The answer is no. That's because, like my colleague Mr. Jaishankar had indicated, when you have to anticipate a bulkhead is roughly 1.5 meters in width. So when it's inserted in the pool, it means that you would, in an existing pool, it means that you would lose that amount of space. That's why a pool that anticipates a bulkhead will actually have to accommodate and be actually slightly longer than 50 meters. So for example, just at a very elementary level, if you're considering one bulkhead of 1.5 meters width, you would have to consider your pool to be of 51.5 meters in length to accommodate the bulkhead. We now increasingly see many pools also looking at the possibility of two bulkheads. Mr. Dharan, hello.
Hi, Hakim. This is Ganesh. Actually, I'm not able to post my question on the chat box.
Okay, sure.
My question here is, even in the last webinar also, we have raised a concern about the heating arrangement, because there should be ambient temperature in the water in the swimming pool so that the users must be comfortable, because some of the countries where the temperature goes down, what is the heating arrangement we are looking for that particular concern?
The heating arrangement, okay, so heating is a different focus topic by itself, and we'll come, I'll be happy to take the more detailed discussion offline. But to answer the question in a more simplistic way, there are different possibilities of heating available. One of the systems that MYRTHA works with, or globally with some of the biggest aquatic facilities, is using a heat exchanger. Now, when architects are designing either big aquatic facilities or big multi-sport facilities, or when aquatic facility is integrated with a larger building or a university complex, what happens is there is a likelihood of having a centralized air conditioning system or HVAC system that from where you could, for example, if you have a centralized boiler or a central, which is providing hot water to the showers and maybe for the laundry, for working, for other jobs, you can have that hot water at a certain temperature brought on to the heat exchanger. So heat exchanger is an element that we have that allows for, then it's a static component. It does not have any running cost. So if you have an existing boiler doing another job, as long as you can get the hot water to the heat exchanger can then be configured to turn off, once the temperatures are achieved. So heat exchanger is one of the most efficient and preferred ways of heating a pool when the larger design is considered, and the swimming pool is not looked in isolation, but as part of a larger integrated project.
But what does the FINA guideline speaks about?
So FINA does not talk about any other than FINA only focuses on the temperature of the water should be between 25 and 28 degrees centigrade. Mm-hmm. It does not talk about what kind of system needs to be used. So even so for example, when we've been building the pools as recently as the World Championships in Korea last year, we've used heat exchangers. Okay. So we and we are able to define what is the kind of flow rate and temperature that needs to come into the heat exchanger for a certain temperature to be achieved in so many days. But so while heat exchangers are the most efficient way from a more holistic perspective, when people look at a swimming pool in isolation and look at heating systems today, heat pumps are one of the mechanisms to be used. So heat pumps, electric heat pumps, are one system to use. Today, solar, depending again which part of the country or in which region you are, solar systems are also being used as a sometimes in isolation, but also in tandem with a heat pump. So during certain seasons when there's not enough sunshine or enough of heat available, to use pure solar energy, then you can use heat pumps in tandem. So these are just at a very elementary some combinations and possibilities that are considered when it comes to heating. Like I said, it's the technical details go much deeper, so we'll be happy to answer further questions with you subsequently.
All right. Okay. Thanks.
Thank you. Mr. Dhanapati Mr. Dhanapati had asked, of having a depth of 1.35 meters to 2 meters, diving is permissible. Like my colleague again, Mr. Jaishankar highlighted, diving, even we ourselves have to at times keep paying attention to the word when we use diving, because there's diving as a sport where people dive off a diving platform, which can be up to 10 meters in a traditional diving environment, and for which you need a minimum depth of 5 meters in the diving well. But otherwise, yes, when we talk about traditionally diving or with the swimming pool context, it's about jumping off a starting block. So when you're jumping off a starting block, like I highlighted, 1.35 meters is the minimum FINA requirement, which is again further defined as the depth required between 1 meter from the wall, where the starting blocks are, up to 6 meters from the wall. And these minimum standards are considered from a competent swimmer perspective. So that has to be kept in mind. Mr. Ashish has asked if the presentation will be shared to the participants. Yes, we will try to share the video recording of this particular webinar with you all. So, we already have the previous webinar up. So those interested, even and those who may have missed the previous webinar, get in touch with us and we'll be happy to share the link to that. And for those who would like a copy of this webinar, let us know and we'll be happy to share that with you. I've answered questions on what is a bulkhead, any leakages at the joints. So Ashish has asked, in the present section, can the bulkhead be moved on the left shallow part of the pool? So I'm anticipating this question came in the context of the Lakshan Sports Academy profile. So the answer is no. In this particular design that has been anticipated for the Lakshan Sports Academy, the bulkhead only moves in the deeper section of the pool. And just to give again examples of the level of detail that we have to pay attention to when you're dealing with a movable bulkhead, we have to ensure that at no point there are elements that could become potential safety hazards in terms of entrapment. And hence, there is a lot of attention paid on all the possibilities. So in the other project that we've shared, let me see if I can quickly in the description. So in this particular project, we have a bulkhead that can come up to. I mean, it is actually parked in the shallow part of the pool, and from the shallow part of the pool will come up to the first stop will be at around the 20-meter mark, where the just before the depth change happens. And again, over here the design was such that because it's a very steep drop, we had to pay attention and give the possibility of a break point at a stage where you can park the bulkhead so that accidentally nobody goes into the deeper end of the pool or loses their footing and panics. So this will come here, and then it gets parked. The first stop for the bulkhead is around this area, the 20-meter mark, and then the second stop is at the 25-meter mark.
Hello.
Hello.
Yeah, this is Ashish.
Yes, Ashish.
Sorry, so this bulkhead not to go up to the bottom of the pool in this. Okay.
No, so that's and that's why if you notice, like I was saying, we have to pay special attention to ensure that there's no entrapment. So if you notice over here, it's flat up to this point, and this is where the first lock will be. So when, for example, since it's a community use pool, when they have a regular public badge, for example, and for crowd control, normally we find people putting a flimsy rope and trying to block people from moving. But this is a bulkhead is a very solid structure, and has a lot of stability. So it's, like I said, a movable wall. And so when you park it in the center, it allows for easier management and allows for better safety of the users in the shallow area.
Okay. And
the second lock comes at the 25-meter mark. Then, in which case there is enough space around, below it to ensure that nobody gets trapped. So when it's parked here in the center, it allows for the pool to be used. Then this part of the pool, the shallow part of the pool, to be used by more. I mean, if you're having only swimming happening, then the children with lesser competence, but who are not learners, they can engage in this area, and the more competent swimmers who are for competitive training can swim in this area, in this part of half of the pool. And then this part of the pool can also be, if you look at this 3D diagram, you have starting blocks, and so this part of the pool then becomes also where you can have competitive swimming happening. Ashish, please go ahead.
So in this section, the diver can access the deeper pool from the below that wall, bulkhead.
Sorry, in the deepest side of the pool?
The diver can access below the...
Yes. Okay. Yes, a diver can go below the bulkhead in this section.
Okay.
Now coming to, I correct me if my anticipation was, your question came over here. Ashish, hello?
Yeah, correct.
Yeah, okay. So Ashish, in this case, like I said, we had to prioritize this section of the pool, the deeper end. And so when people want to train 50 meters, the bulkhead would be parked here. And the competitive swimmers who want to train 50 meters would train 50 meters. And then this gets moved back in the center. So this in this specific case, the bulkhead comes up to the bottom, and the depth over here, this area is 2 meters deep. So here it's flat and comes and gets parked over here, so that there's no room for any entrapment. If it was in the shallow area, if the bulkhead had to go into the shallow area, then it had to be only 1 meter in height, as you can imagine.
Yeah.
And that when it moves into any of these areas, which is 1.35 meters, can create an odd space that can create a risk of entrapment.
Mm-hmm. Okay, thank you, Hakim.
Welcome. I would like to thank again every one of you for participating in this webinar, and do share your feedback. And it's important for us to anticipate your requirements, and we'll be happy to go more in detail in subsequent webinars. Thank you very much, and wishing you and your family the best, and stay safe. Thank you.